Hello and welcome. We're going to talk about something we use every single day, but maybe don't think too much about our home network. We're going to lift the hood on that little blinking box in the corner of your room and see how it actually connects you to, well, the entire world. Let's get right into it.
It feels like magic, doesn't it? You type something, hit enter, and almost instantly you've got answers. But in that tiny split second, your request embarks on this absolutely incredible journey. So today, we're going to follow one single piece of data from your computer all the way out to the internet and then all the way back home.
So before your search for, say, cat videos can even dream of reaching the internet, it has to navigate its own home first. This very first part of the journey happens on what we call your local area network, or LAN for short. You can think of it as a private, exclusive club for all of your own devices. Yeah, just think of your LAN as your actual household. Your phone, your laptop, your smart TV, your gaming console, they're all members. And to get a message outside of the house, your laptop first needs to talk to the device that basically controls the front door. This internal chat is always step one. Now, way back in the day, networks used a thing called a hub. A hub is kind of like a person with a megaphone. When it gets a message, it just shouts it out to every single device on the network. It's noisy, it's messy. Thankfully, modern networks use a switch. And a switch is so much smarter. It's like an efficient mail clerk that looks at the address on a letter and delivers it only to the person it's for. It's way more efficient, and it's a huge reason our networks are so fast today. So you might be wondering, how does the switch know which device is which? Well, every single device that can connect to a network has something called a MAC address, burned right into its hardware from the factory. It is a permanent physical fingerprint for that device. And on your local network, just inside your house, the switch uses this MAC address to know exactly where to send each little packet of data. Okay, so your laptop used its MAC address to send a data packet to the central hub of your home network. The local delivery is complete. But now what? How does that packet actually get out of your house and onto the great wide internet? Well, for that, we're gonna need a gateway. And this is where the main character of our story finally enters the scene, the router. A router's whole purpose in life is to connect different networks. It is the gatekeeper, the bouncer that stands between your private little home network, your LAN, and the huge public network that is the internet. Now, if there's one thing you take away from this, let it be this distinction. It's super important. A switch handles traffic inside a single network, like an office mailroom, just delivering letters from desk to desk. A router, on the other hand, manages traffic between different networks, like the central post office for an entire city. Switches use those local MAC addresses, but routers use global IP addresses to send your data all over the world. And this right here, this clears up a ton of confusion for people. That box you got from your internet provider, the one you call your Wi-Fi router, it's not actually just a router. It's almost always a combination device. It's got a router to talk to the internet, a built-in switch to connect your wired devices like a PC or a game console, and a wireless access point to create that Wi-Fi signal. It's a real triple-duty powerhouse. Okay, so we've mentioned that routers use IP addresses to send data across the internet. But hang on a second, where do our devices even get these IP addresses in the first place? How does that magic just happen? Think about it, right? When you get a new phone or a friend comes over and asks for the Wi-Fi password, you don't have to go into some complex settings and manually assign them a network address. It just works. So how does it do that? Well, the answer is a neat little protocol that acts like an automatic receptionist for your network. This little bit of magic is called DHCP. It's a service that runs on your router, and its job is to manage a pool of available IP addresses for your local network. When a new device joins, DHCP is like a friendly hotel clerk. It just hands the device a temporary room key, a unique private IP address, so it can be found on the network. And it all happens through this lightning-fast, four-step conversation that we call a handshake. First, your new device connects and basically shouts out a discover signal, asking, "Hey, is there a DHCP server here?" Your router hears this and makes an offer, saying, "Yep, and you can have this IP address." Your device then requests to use that address, and finally, the router sends an acknowledge to make it official. This all happens in milliseconds, totally behind the scenes. All right, our data packet is finally ready to go. It's got its own private IP address from DHCP, and it's been handed off to our gateway, the router. Now it's time to leave the cozy confines of home and begin its epic journey across the vast global network of the internet. So remember that local MAC address? Well, an IP address is a global address. one that can be read by any router anywhere in the world. It works exactly like a postal address. Part of the address points to the general network, kind of like the neighborhood, and the other part points to the specific device, the house number. You know, your request isn't sent as one giant file. It's chopped up into these tiny little pieces called packets. Each and every packet gets stamped with the destination IP address. The internet is really just this massive, sprawling web of interconnected routers, and each router it meets along the way reads the address and makes one simple decision. What's the next best hop to get this packet closer to where it's going? Then it zips it along to the next one.
So the packet makes it. It arrives at its destination, let's say it's Google servers. Google does its thing, finds your search results, and sends a response back. But it only knows your public IP address, the one for your entire house. So how in the world does the response find the specific laptop that made the request, and not your phone or your smart TV?
This is the final, and maybe the most clever, trick your router performs. It's a process called Network Address Translation, or NAT for short. NAT is what allows all the different devices on your private home network, each with its own private IP address, to share the single public IP address that your internet provider gave you. And this shows you exactly how it works. It's brilliant. When your laptop sends a request out, the router keeps a little note in a ledger. It jots down, okay, the laptop at private address 192.168.1.10 just asked for google.com. Then it sends that request out using its public address. So when the response from Google comes back, the router just checks its ledger, sees who made the original request, and forwards the packet to the correct device. It's just some fantastic bookkeeping.
And this quote just nails it. Because of NAT, your whole collection of devices, your laptop, your phone, everything is basically invisible, hidden behind that one single public address. This also gives you a pretty great natural layer of security, because computers out on the internet can't just directly see or try to connect to your individual devices. They can only talk to your router. So when you put it all together, the directing of local traffic, the automatic address handouts, that journey out to the internet, and the clever translation on the way back, one device really stands out as the MVP, doesn't it? It's your humble router. It's a traffic cop for your home, it's the master translator that lets all your devices share one connection, and it is the gateway to your entire online world. So the next time you hit enter, maybe give a little nod to that blinking box. It's doing some pretty incredible work for you.